Okay, so the last one we're going to graph, the last transformation, graph with transformation is tangent, okay? So tangent, as you've noticed from the unit circle, from your tables that you filled out for the unit circle, acts a little differently. Because remember, tangent is, so to find tangent of an angle, you're going y divided by x. There's no 1 in there. So because of that, it acts a little differently than the others, than cosine and sine do. Okay, so because of this, you see the graphs here. So the graph, so for the graph, it kind of does, it looks like a cubic almost. And it just repeats. So it repeats forever and ever and ever like that. And then you notice there's some asymptotes because on the table, right, if you remember on the table, there were some spots where tangent was undefined. There was no tangent. There was no answer because we got 0 on the bottom because x was 0. Anytime x is 0, tangents won't exist. Okay, it's undefined. Okay, so a couple things different. First of all, the period. So the period is only pi. So one full period of tangent is only lasts for pi. You can see it from here. It goes from pi over 2 to 3 pi over 2. It goes from negative pi over 2 to pi over 2. So it just lasts 1 pi. Okay, the domain of this is just tangent of x. This is not any transformation. So this is the parent graph, strictly the parent graph here. Okay, so the domain you can see all real numbers except odd multiples of pi over 2. Pi over 2, 3 pi over 2, negative pi over 2. That's where the asymptotes are. The range is all real numbers because the graph is going to go up to infinity and down to infinity, negative infinity. Okay, so x-intercepts occur midway. It's an odd function. Don't worry about that. We didn't talk about that this year. Okay, but that's what it looks like. That's what the tangent graph looks like. Okay, so a couple things. So just like always, excuse the handwriting. I'll try to explain it best I can so that any handwriting doesn't make sense, we'll be able to correct that. Okay, so again, if you need to pause it, pause it. So A is going to determine amplitude, stretch and compress, okay? And if A is negative, that means it's going to reflect over the x-axis. That means, yep. B, period length. Now, regular period length for this is going to be pi, right? So B will determine period length. If it's shorter, if it's longer, okay? C is phase shift. So if it's a plus C, it's going to go left that many units. If it's minus C, it's going to go right that many units. And then D is a phase shift. Positive D, up that many units. Negative D, down that many units. Okay, so first thing, we have a new graph. Example number 1, y equals 2 tangent x over 2. So I rewrote it. All I did was just rewrite it. It's the same thing. I just, instead of x over 2, I wrote 1/2 x. Another thing, one thing I made a mistake on. Since the period of regular tangents only, of the parent graph is only pi, to find period is just going to be pi over b. That's just for tangent, okay? And cotangent, I should say. But we're not having to graph cotangent, so don't worry about that. But that's that. So it's pi over b. So now, so when I'm doing this, so I've graphed, so over here, I've graphed the parent graph. Okay. So now what I got to do is figure out what transformations are taking place. Well, first of all, amplitude is 2, so it's going to be stretched. Okay. Period is going to be 2 pi as opposed to 1 pi like it regularly is. So it's going to be a little wider. Okay, so it's going to start in the same spot because it's not being shifted right or left. It's going to start. There is no phase shift. So it's going to start. So I'll use green for this one. So the new graph is going to get wider and it's going to have a period of 2 pi. So that means it's going to extend. It's going to extend to pi over here and negative pi over here. The asymptotes are going to be here. Okay, so it's going to be wider than usual, okay, because the period is extended. Okay. Okay, so for this guy, everything looks, see, so tangent, there's no amplitude, x, tangent of x, so the period is still gonna be pi. So the only new part is this plus b, plus 1, plus pi over 4. Okay, so what that means is everything's gonna be the same. Amplitude will be the same. Period is still gonna be pi. So period is still gonna be pi. Okay, the only thing is we're gonna move left pi over 4 units. So every dot will move left pi over 4 units. So let's look at this first guy here. So this dot here, let me use a different color. This dot here is gonna move left pi over 4 units. Okay, so instead of 0, it's gonna be at negative pi over 4. Okay, so let me erase the... Okay. Everything moves that way, though. So the asymptotes are also going to move that way. So the asymptotes are going to move left pi over 4 units. So instead of pi over 2, it's going to move to pi over 4. So the asymptotes are going to move this way. Same thing in this one. This will be where the new asymptotes are. So let me erase the old ones. Okay. And the graph, other than that, the graph is the same. It's not wider. It's not, there's no stretch. There's no compression. It's not, the period isn't shorter or longer. It's going to have the same basic shape. Okay. And then graph another period. So again, the asymptote is going to be pi. So pi over 4, pi over 1. So this one is going to be right here. Because this is positive pi over 4 plus pi. So if I go positive pi over 4 plus a pi, and then it would be 5 pi over 4, which is this one right here. Okay. So the there, up, and down. Okay, example number 3 is y equals negative tangent of 2x. Okay, so first thing, amplitude is 1 because the absolute value of negative 1 is 1, but it's going to reflect over the x-axis. So to the right, you see the parent graph, so that means it's going to be reflected. It's not going to get wider, it's not going to stretch, it's not going to compress, it's just going to be reflected. And then next, the period is not pi, it's pi over 2. So the period is going to last even shorter because the distance from here to here is a full pi. But what this is saying is the distance needs to be even less. Okay? So what's going to happen here are the asymptotes are going to get shorter, or closer together, I should say, not shorter. Okay. And then the shape is going to stay the same. So obviously it's going to be a little more, looks like it stretches a little bit because the asymptotes have come together more, but that's essentially what it's going to look like. It's one period there. So let me erase this. Okay, so the next one, so it just repeats itself. So the next one, so that means the next asymptote will be here. You'll have a dot right in the middle of the asymptotes. Okay, but I forgot one thing. I forgot about the reflection. Okay, so it's going to look like that, just reflected over. Okay, so let me try a different color again. So this guy is going to come down. This guy is going to come up. Try to erase just this part here. Okay, so the same thing's going to happen here. It's going to repeat itself. That's the nice thing about graphing trig functions. They repeat themselves. because they're periods, they're cycles. They repeat themselves. Okay. Periods got shorter. Negatives made it reflect over the x-axis. We are done.